a sphere is. Obviously, we know what a sphere is, but to get the formula for a sphere, there's this real complicated process. On page, so they actually show this on page 882. If you honestly want to get into this a little bit, they talk about ever taken apart a baseball before? Some of you probably not. Some of you probably have. Well, if you took out the stitches, right, and you laid the baseball flat on page 880, you would have the piece just like that. You'd actually have two of those. So basically, they're saying, well, how can I find the surface area of those shapes to get there? And then they go through a process of, on page 882, talking about the volume. And they talk about a specific process there where they think about cutting out one triangle or one pyramid of the shape and using that one pyramid to do calculations to figure out the actual formula, right? So I'm saying if you really want to get into that, you can get into it a little deeper. I would assume that most of you are going to say, yeah, I have no idea what you're talking about. So the one year I did try to kind of explain the pyramid thing, and after 5 minutes, the look in the eyes of people were so far gone that we just stopped. So if you really wanted to get into some of that stuff, let me know. We can sit down and talk about it. So basically, we're going to go the layman's terms, right? So what's a sphere? Okay, so how can you describe that in geometrical terms?
3D circle.
Okay, so what's true about a circle?
All points. 360 degrees. Never a straight line.
Exactly right. So the same thing, right? From a center, it would be all points equidistant from that, right? Kind of like our circle. So this is where when we're talking about what Gabe was getting into, we would say that when we talk about a sphere, we're talking about the perfect square, right? In a parallelogram. Well, now it's a perfect circle. So yes, he's technically right that an oval is, or a sphere is an oval, but this is that special oval. So when we get there, we're talking about all the things that we've already talked about in a circle. So we still could have a radius. What's the radius?
Half the distance.
Half the diameter.
Okay, so it's half a diameter, but what?
Half the distance.
The distance from the center to the outside, right? So we still talk about a radius. We can still talk about a chord. We can still talk about a diameter. Okay, so again, this is little r. A chord is simply what?
A line that doesn't go through the center. It hits the circle at one point.
No.
No.
2 points.
No. It's 2 points.
So a chord is a segment with the endpoints where?
On the edge of the circle. Outside.
Right. On the edge. So in this case, the edge of our sphere. So then a diameter, is a diameter a chord?
Yes.
Yes. But then we have to say what?
Through the center.
Yeah, so this is a chord through the center. So again, we're getting more specific, right? Or this is kind of like the square example again, right? And then they want to talk again about a tangent. So we had two different versions of tangent, right? We talked about a tangent when we were talking about trigonometry, SOHCAHTOA, right? And then we had a tangent when we were talking about circles. A tangent with a circle touches the circle how many times? One time. Okay? So a line, it could be a segment, could be a ray, when it touches a circle exactly one time. And do you remember how you could prove that a tangent was a tangent? The tangent and a radius did what to each other?
Intersected.
Okay, where they intersected was the point of tangency, and what happened at that point of intersection? They formed a 90-degree angle. Okay? So those are things that we've talked about before. All right? From there then, remember when I told you about the samurai sword and we had a basketball? And when we took that samurai sword and we would cut it straight down the middle of the basketball and we would hold each edge of the basketball or we would palm the basketball, we would be looking at what? A circle, right? And if you did it exactly down the middle of that circle, or you think about the earth and that circle right down the middle, we would call what on the earth? Is the equator. And what's true about the equator?
It's hot.
Okay. What else?
It's the widest,
Longest
longest longitude.
Okay, so what kind of circle would we have?
Two semis.
It's the biggest, right? So if you slice a circle exactly in the middle, you would form, what would you call it?
Big circle. Semicircle.
It could be a semicircle.
It's just called the biggest circle.
But in this case right here, if you do it right in the middle, this is called a hemisphere. Right? We're going back to the equator again and the earth. And when we talk about a hemisphere, you're talking about a great circle. And a great circle then is the biggest circle that you can possibly make. Does that make sense to everybody? So again, if this is a ball, I'm going to chop that baby right down in the middle of the ball. So what happens is then I have basically this shape right here and this shape right here, right? Well, they're saying if I tilted this and looked at this side of it, it would actually be a circle, and that's the biggest circle. But I could continuously chop it with my samurai sword again, right? And as I continuously chopped it, what would happen to all of my circles? They would just get smaller and smaller until I get way down to the end. That makes sense to everybody? So this great circle is what we want to concentrate on. And actually then they call this here and here the poles. So it's kind of like the North and South Pole, right? If we, again, talk about the Earth. That's kind of where they come from. And as I said then, so if we do it at this exact point, each one of these is a hemisphere then. And they would be exactly the same, as long as we can prove that it's right down the middle. So again, then they start doing the baseball thing for surface area. If you take a part of baseball, you end up with, if you didn't open your book, it kind of looks like this shape. I can't really draw it, I'm not gonna lie to you. Something like that, right? And so there's another one over here, and you bring them together and you stitch it back up and you make the baseball. Well, again, they're talking about, well, how can I find the area of that? Okay? Well, they go through a process, but to simplify things, we were just going to say the surface area, if you would go through this whole process, is simply going to be 4 pi r squared. So basically, this is because of the way that you were just look at certain things. Obviously, we have to include pi r squared because essentially this is what shape? These are circles, that's where my pi r squared. So essentially, if I laid that other flap over top of it, it's saying that I have 4 of those pi r squareds, and that's how I would get my surface area. Okay? So from there then, if we talk about the surface area of a hemisphere, so this is for a sphere, now we go to a hemisphere. So again, what's the difference between a hemisphere and a sphere? It's half, right? So, but think about this. So if I actually had I should have brought a tennis ball. And I cut a tennis ball in half, you can see that great circle, right? But if I'm thinking about the surface area, what am I going to have to calculate? Well, I'm still going to use this, right? But what would I do with this? What would I have to do to this? I'd have to take this times or divided by 2 or times 1/2, right? Everybody agree with that? And then I have to add the what? The area of a what? Of a circle, which is my great circle, right? Because it's the outer portion of that half circle. Does everybody understand what I'm saying there? So I'm going to include, so what's the area of the circle? Pi r squared. So if I essentially simplify this, obviously my 1/2 and my 4 makes this really what? 2 pi r squared. But if I have 2 pi r squared over here plus another pi r squared, essentially the surface area of a hemisphere is actually what?
2 pi r squared.
How about 3 pi r squared? Right? Because this is a 1 right here and they're the same things, right? So 2 plus 1 makes it 3 pi r squared. Okay?
So basically we could use then the 3 pi r squared when we solve.
If you're doing a hemisphere, yes, I would use this. They show it in the book as 1/2 4 pi r squared plus pi r squared, but we just simplify it to make it easier for you. Okay? So this is for surface area. Now, what else have we been talking about? We also talk about the volume. So again now, they just kind of group these together because this is the only one that really is a ball,
Is
right?
there no lateral area?
So, okay, that's a great question. Is there a difference between the lateral area and the surface area?
No, not in this case.
Because think about what was the lateral area when we had sides? The guts, right? Compared to the surface area, it included all of the sides, which were the bases and the guts. Well, now it's just one curved area. So essentially, you're talking about the circumference in a sense. Okay, so no. The simple answer would have been no, but yeah. So then we get into the volume, and if you notice this here, it says, and this is where you would have gone back if you would have looked through that process on page 882. They relate this to the volume of a right pyramid. So notice in a right pyramid, we proved that 2 days ago, right? When we took our triangular pyramid and poured it into the triangular, or the rectangular pyramid into the cube. Okay, we proved that it was 1/3 BH. And then, obviously, it's going to involve a sphere. So you're going to take the 2 and do that, right? And that's what the process that they go through. But essentially what they come up with is that this H right here and R essentially are the same thing. So the height of a triangle in that sphere, if you would cut into that sphere and pull it out, you'd have a height of a triangle. Well, that height of the triangle is essentially the radius of that sphere. And so H and R are actually the same thing. So basically, you're kind of combining the 2 here and assuming that H and R are the same thing leads you to this formula right here. So the volume of again, we're going to do it to a sphere first, is 4/3 pi r cubed. And essentially, again, that came from combining these two things. 1/3 times 4, and then my pi and h and r squared are the same thing. So they came up with 4/3 pi r cubed. Okay? And so then, if you think about the volume of a hemisphere, what's the difference again?
It's half.
It's half, right? So if I just do half of this, am I good? Compared to what we had to do over here. Do I need to really include that big circle in the volume? Not really, right? So here we had to include that extra circle because we needed the flat surface on the top. including the half ball shape. Here, we don't need to include that when we go from a sphere to a hemisphere. So the only thing you have to do is take this formula right here and do what to it? Divided by 2. So if I take 4/3 divided by 2, what do I get? I get 2/3. So the volume of a hemisphere is equal to 2/3 pi r cubed. So again, basically you're just remembering now, or adding on to your list of formulas that we've already had, and we need to include 1, 2, and then 3 and 4 over here. Okay?
Do you also do one the volume of a false figure and just divide it by 2?
Yeah, you can do that. Yeah. Okay. So let's look at a couple of them because there's actually pretty good examples in this section. Any questions with any of those things? Now again, like I said, if you want to get technical, come in and we'll sit down and we'll get into technicalities. If you want to do that, Gabriel. Okay. So here's my first one. So again, the biggest thing that I have to remember is I need a radius, right? So if they give me a diameter, obviously I have to do what? Divided by 2. So in this case, it says find the surface area of the sphere. Basically, I'm taking that number and I'm throwing it into the problem, right? Or the equation. So all I'm doing is throwing it in here. Remember now, this is the order of operations. So I got a square first. Remember, this is r squared. And a big problem in pre-algebra today. Okay? They were just taking this radius times 2. Remember, it's radius squared. Radius times itself. And then times 4, and then times pi. And again, you can use the button, or you can use 3.14. So, what do we get? 254.5. Now, remember, we're still talking about surface area, so my label's got to be what? Squared. Inches squared in this case. Okay? And again, if you used 3.14, your answer is probably a little off, or a little different. It's definitely not wrong. Okay? Everybody okay with that? We seem kind of out of it today. This is, I think, a little better. No, not yet. The next one. So this one's pretty straightforward also. So now we're just throwing it into this one, right? And again, you could go back up here and use this longer version, but this is way simpler to me. So we're basically doing the exact same thing. We're just taking our radius, squaring it, and taking it times 3, and then times pi.
We wouldn't have to multiply by 2 to find the whole sphere.
No, because they ask you to find the hemisphere.
The hemisphere.
If they ask you to find the whole sphere and gave you a hemisphere, then you would do that times 2 at the end.
So a hemisphere is just a semicircle.
It's just half of the sphere.
Half of the sphere.
So it sounds. That's not
Well, in a sense, but not really. Okay. It's kinda, but not really. What do we get?
129.03.
See, they do the long version. I think that's
They
just
didn't round
complicated.
right either.
What?
They didn't round right.
They did?
That's what I got.
They're just rounding to the nearest 10.
Yeah.
I think this is the one that's good.
All
Alright, let's look at this one. Find the surface area of a sphere if the circumference of the great circle is 10 pi feet.
Whoa.
So think about what they're saying here. Okay, think about what they're saying here. Find the surface area of a sphere. So somewhere along the way, I got to use this formula right here, right? But it says that they gave me the circumference of the great circle. What's that mean? That means the perimeter of the great circle is 10 pi. So what do I take 10 pi and set it equal to?
2 pi r.
2 pi r or pi d, right? Does everybody understand why we're doing that? Because it says, what is the circumference, right? Now, in a lot of these problems, this is really easy because watch what happens. right? That's my formula. Now, if those of you that liked pi d for the circumference and didn't want to learn both of them, then the first thing that you have to do is divide by 2, right? Or at the end, you would have to divide by 2. But this one right here is real simple, right? So my r is what?
5.
And that's real easy. Everybody see how we got 5? And then what do I have to do with my 5?
Put it in the equation.
Then I got to go back and put it back into this equation. So you just had to find a radius in the first place.
So the diagonal you do is just have it to them.
Right. So in that case, then you could do pi d and figure out what your d was. Then you would have gotten 10, and then you would have taken 10 divided by 2.
Oh, okay.
And then taking it back to
So
that.
you just have to find a radius.
You just got to find a radius somehow. So that's where, even if you like pi d, you can still get the answer. Okay? Gabriel Scott Wilson,
Yeah.
anything? You're okay with this?
Yeah, this is a great point.
Did you also see?
So this one changes just a bit, right? This one says find the surface area of a sphere if the area of the great circle is approximately 220 square meters. So now, instead of, at the very beginning, taking that problem and setting it equal to 2 pi r, we're going to set it equal to what?
Put 4 pi r squared.
Pi r squared. Because it says that right there, 220, is the area of the great circle. So I got to first find my radius of my great circle, right? The radius of the great circle and the radius of the sphere are the same thing. So this one right here, I'm going to take pi r squared is equal to 220, right? Now don't get confused with this one compared to the other one. The other one had pi in it, and that's okay. When we divide it, the pi's just cancel each other out. Here, remember, pi is just a number. So when you look at this, and some people say, well, I don't have a number on the left-hand side. I really do, right? Pi is 3.14. So what's the first thing that I'm going to do here? I'm going to divide by pi, and then with that answer, I have to do what? Take the square root, because it says r squared is equal to that. And to get rid of something squared, I take the square root of it.
That's the answer.
So take 220 divided by pi, and then take the square root of that answer. Now that's not my answer though, right? That's just your r. Now here's where you got to really be careful. Do not take that answer and round it. Okay? You want to be as specific as you possibly can. So do not round that answer. So when you do this, see, they went and rounded to 8.4. I would keep that as a long decimal to be as specific as we possibly can. And then again, we're taking it and putting it back here. So essentially, instead of 8.4, which they rounded, I would have used that whole formula. Or, yes. Okay? So again, make sure that you use your answer key or you just continue to do it. So essentially, Gabriel's radius, he would have squared times pi times 4.
So we really didn't need to find the radius, we could just plug it back in, because that's just
The diagonal?
is that right?
Did you get 80?
I didn't know.
I had to find the radius.
Never mind.
What's the answer?
What's the answer?
880.
886.7. But again, look at the difference. Because they rounded to 8.4, so yours could be drastically different. What's yours?
880.0000000033.
880.
I said
I just
80.
said 80.
Was your number less than 8.4?
Yes,
Yeah.
8.26.
Okay, so yes, it's actually less, so yes, yours should be smaller than it.
It's 880.
Does that make sense what I'm saying?
Yeah.
So what I'm saying is, if your number was 8.423247, right, it would have rounded back to 8.4, but your decimal would have been higher, so it would have been bigger than their answer. Get what I'm saying there?
Yeah.
Okay? So yes, I would guess you're right. But look at the difference, right? That was 6 points difference. That's a big difference, right?
Oh, so, I know what I was trying to say. So,
I understand what you're saying now, because you had an area.
Yeah, so like, we did 200.
Can you take that times 4?
No, I'm not, like, when we were finding the radius, wouldn't we just done 220 divided by pi?
Watch this. In this one right here, in all honesty, all you had to do is what?
Take it, divide Divided by, you didn't need to square it.
And then plug it.
All you have to honestly do is take it times 4.
That's why I thought.
Because this is pi r squared right there,
What the heck?
right?
Oh, yeah.
So we did it the mathematical way, but if you would have stopped and thought about it, they're telling you that that is the area. Well, the area is this. That's what we want. So when you're doing the surface area of a sphere, you're looking for that area of that great circle. So really all you had to do is take 220 times 4. Does that make sense?
Why'd you tell us that earlier?
Well, because I wanted you to do the math. But again, is it really realistically correct?
No.
Because look at their 220, right? It's approximately 2. So if we're building a rocket ship, we probably don't want to get on their rocket ship,
I would.
right? We want to get on ours.
I would.
You're still going to get on it?
Only
You
if
don't
it's,
care?
only if it's made by Gabe Scott Wilcher.
It would be exciting.
He's gonna gauge rocket ship.
Another rocket ship.
Yes,
He's gonna build this when he's president.
maybe.
Yeah.
Or at least tell somebody to build it. Gabriel,
Don't forget about us, we get.
what is my job going to be when you're president?
Gabe has affiliation.
It's like security.
Oh yeah, I was a Secret Service guy, wasn't I?
Yeah, we hit it.
Find the value of a sphere with a great circle circumference of 30 pi.
I'm too tired for this.
So think about it. What does that tell you? So again, what do I need if I'm going to find the volume? I need the radius. So if they give me the circumference again, I'm going to take 30 pi and set it equal to what? 2 pi r. And again, you could do pi d, but then you'd have to divide something.
We could just take it divided by 2.
2 pi.
Because it's diameter times pi.
Huh?
If 30 is the diameter, just divided by
But 30 is not the diameter.
There it is, the circumference.
30 is the circumference.
Yeah, and the formula is
Basically, you're taking 30.
pi times diameter.
You can't see it.
No, you have to set it up to 2 pi r, then divide by
So yes, you're going to divide by 2.
Yeah.
Yes, absolutely. But you just got to remember to divide by 2. If you use 2 pi r, then the 2's already in there. So essentially it's the same thing. They're just showing you 2.
Okay.
Okay? So what do we get for r? 15, and then I'm going to bring it back here. So essentially this one's like the first one we did, right? But remember, then I'm taking 15 and cubing it. Remember now, what's 4/3 mean? Well, you got 2 options. You can make it into a fraction and multiply by that fraction, or you have to take this times the 4, and you can divide by 3 at the end. That's totally however your melon works. Or you just put 4/3 as a fraction, or you use the fraction key, or however you do it. Or the very first thing you can do is 4 divided by 3 and take that answer times pi times r cubed.
How do I cube on my calculator?
Oh, okay, so if you want to cube something, you should have maybe a button that looks like a little up arrow, or a button that looks like either y to the x or x to the y. And so here you would take, so like in this case, we would have taken 15, hit that up arrow, and then put 3.
I have x to the third.
Okay, some of them have x to the third right in there, yes. So this little up arrow would do you any exponent. So if this was r to the 15th, I could hit 15 raised to the 15. That's what that caret key means. But you might have this letter too. X to the something or y to the something.
Yeah.
So we go like this.
Where's your button? Yeah.
What?
Yeah.
7 or 15.
What if you have e to the x?
I don't know what that is.
Mr. K.
So if you're gonna put it all in there, you just gotta make sure.
E
ln.
to the x.
ln, that's for logarithms.
Oh.
That's an algebra 2 deal. So, everybody get an answer? Oh, what was the answer?
688?
No.
Nope.
14,137.2. You didn't use the right radius, Gabriel. You used 5 point something. It's 15.
Why is it 15?
30 divided by 2 pi r. So 30 divided by 2 is 15. Everybody else get 14,137? Okay. I think that's probably about it.
So tomorrow we're doing the last two sections, or today?
These are good.
Say it one more time.
Are we using the last two?
That's the only way.
What do you want to use?
Okay, going 6, 7. She's going
Alright, hey! Here's the assignment. So the question is that Ms. Streckman wanted to know, do you want to do this section on a check for understanding, cones, and pyramids, or prisms and cylinders for volume? You want to do this?
I said this one.
We're doing one or the other.
Or are we doing
One or the other?
This one.
This one?
This one.
First one. That's the one I did.
Well, then you have to do the homework today.